Welcome to IsiZulu tutoring kusase uYupeter eFosloras. Sizokwenza ama-rate of reaction i-chemistry grade 12 paper 2. But before siqhubeke ngizothanda ukubonga kakhulu kwabasubscribile ukuze i-channel ifike lapha ekhona. Ngiyabonga kakhulu. Ngicela ukuthi abangaka-subscribe besubscribe. Nanoma niwabukela ama-video ngicela ukuthi niwa-like, ni-comment futhi. Nanoma ngathi nje siyabonga. I-comment nayo leyo siyayidinga bese uthena on i-notification bell so that mangipost i-video entsha uzoba notified. Remember kuma lower grades sike safunda nge-reaction. Masingathatha nje le hypothetical reaction ku-reactor u-A no B to form u-C no D. Ungakwazi ukusho ukuthi u-A no B uyini, u-C no D bayini. U-A no B siyazi ukuthi ama-reactants angithi. Ngoku-understanda kwethu ama-reactants siyazi ukuthi ama-reactants aba-used up. And then u-C no D siyazi ukuthi ama-products. Ngoku-understanda kwethu ama-products siyazi ukuthi ayafomeka ama-products. Ukuze kube nama-products kumele ku-existe ama-reactants. Bese yadleka ama-reactants meaning abe-used up bese kuzofomeka-ke ama-products. Into enjalo eyenzakalayo. Uma uyi-define i-rate of reaction uthi the rate of reaction is the change in concentration of reactants or products per unit time. Yona-ke i-rate of reaction inalo-ke formula njengoba ubuzwa nje ngo change no concentration no time kusho ukuthi khona iformula le rate of reaction. Iformula le rate of reaction lithi rate of reaction equals change mathematical delta leya triangle leya. So change in concentration of reactants or products. Concentration representwa ama square brackets ku chemistry over change in time njengolibona ke formula. Okay, asiconsider futhi reaction yethu A no B to form C no D. Ngoku understanda kwethu sazi ukuthi A no B ba ama reactants kusho ukuthi baba used up. Uma ungayicabanga in terms of i-change ungavuma ukuthi mhlawumbe u-A no B baba ne-negative change ngoba bayadleka. So kusho ukuthi iformula le rate of reaction masikhuluma ngo-A no B specifically kuzoba u-negative change in concentration of reactants meaning A no B over change in time. I-change in negative now because isikhuluma ngama-reactants and aba used up. Angazi noma niyangithola. Asiconsider le graph lena, i-graph abasinikeza yona i-graph of concentration versus time of A and B. Uyabona kuma y-axis sine concentration and then kuma x-axis sine time. Now i-graph yethu at time 0 siyayibona ilapha phezulu ku x meaning at its maximum. Angazi noma niyangithola. Kusho ukuthi before i-reaction yenzeke ibikhona i-concentration and ibi at maximum. Lokho kusho khona ukuthi kusho ukuthi ama-reactants lawo ngoba ama-products awabibikho uma ingakaqali i-reaction abakhona as a result of ukudleka ka-A no B. So i-graph lena eshow i-concentration ka-A no B masingavumelani iqale ku-x. Yini into engiyinothisayo as isikhathi sihamba i-graph lami lokhu yehla as isikhathi sihamba ize i-reach u-point Y. Mase ngiyibuka mina i-graph yami from point Y to point Z isi-horizontal manje i-graph yami. Njengoba ngisho ama-dotted lines lawana asho ukuthi now i-concentration ayibisashintsha. Bengifuna ukubonisa laphana ukuthi ku-X and Z i-concentration manje isi-constant ilapho kuqala khona ama-dotted lines ayisehli ayisakhuphuki. Leyo nto isho something about i-reaction but sisazofika-ke kuyo. Now i-graph singavumelana ukuthi akuyona i-rate of reaction kanti thina sikhuluma nge-rate of reaction. Eyani-ke le graph ye-concentration versus time. Siyayibona i-title isho kanjalo vele. But uma ufundile uku-analyze ama-graph bakutshelile ukuthi every time uma u-analyze i-graph zikhathaze nange-physical quantity erepresentwa i-slope noma i-gradient ye-graph ukuthi i-gradient yale graph iyini-ke yona. Masingabuka i-gradient iformula le-gradient lithi m equals change in y over change in x. Yini change in y? Into kuma y-axis i-concentration kusho sino change in y okusho ukuthi change in concentration in our case over change in x kusho ukuthi change in time in our case. Ubani change in concentration over change in time? Buka iformula lapha phezulu iformula le rate of reaction ukuthi lithini? Lithi change in concentration over change in time. Remember ama square brackets asho i-concentration angithi. Kusho ukuthi i-gradient yale graph representa ini? I-rate of reaction. Kubalekile ukuthi ukwazi-ke lokho. Sisazokusebenzisa kakhulu i-fact ukuthi the gradient of the graph is the rate of reaction. Asiconsider futhi i-hypothetical chemical reaction yethu u-A no B baya-reactor to form u-C no D. Siyavumelana ukuthi u-C no D ama-products kusho ukuthi bayafomeka. Mawucabanga in terms of i-change ngoba befomeka kusho ukuthi bane-positive change. Therefore, iformula le-rate of reaction masikhuluma ngo-C no D lizovele lithi rate of reaction equals positive change in concentration of products over change in time. Angazi noma niyangithola. Now bangidrawela igraph lapha, igraph concentration versus time. Uyayibona leya graph yami at time 0 i-concentration was also at 0. Kusho ukuthi initially ebengekho u-C no D. But masilokhu siqhubeka isikhathi sihamba kusho ukuthi lokhu yenzeka i-reaction ulokhu uyakhandeka u-C no D, uyakhandeka u-C no D, uyakhandeka u-C no D. Kusho ukuthi igraph yabo siyayibona kuyayenza isense ukuthi lokhu ikhuphuka i-concentration, ilokhu ikhuphuka i-concentration ngoba bayafomeka until ize reach u-point X. From point X to point Y uyabona ukuthi igraph yami isi-horizontal. Kusho ukuthi i-concentration isimile lapha ku-Y nje ubona ama-dotted lines esuka lapha ku-Y. Concentration isiyileyo amount ayisehli ayisanyuki, but le graph ay represent the rate of reaction. Suyazi already ukuthi yini represent the rate of reaction is the gradient of the graph. Sivumelene lapho. Kubalekile ukuthi ukwazi ke lokho ukuthi graph yama reactants iyehla, yama products iyakhuphuka. I-reason ama products ayafomeka, ama reactants aba used up, meaning negative change kuma reactants, positive change kuma products. Now because isazowasebenzisa kakhulu ama graphs ayavela na kwi-exam, it is considered na graph basidrawele sine graph of concentration versus time. Bayidrawa ke graph yethu uyayibona ukuthi ya increase ukuthi kushuthi graph yama products lena ngoba ya increase. Now ifike ku point X to point Y yabanjani yaba horizontal. Kusho ukuthi amount isilapha ku point A, angazi noma niyayithola leyo nto leyo. Now let's consider i graph yethu at time t1 bese siconsider i graph yethu at time t2. Mangathiwa mina ngifuna i rate of reaction at time t1, ngizodraw a tangent on the graph at time t1 bese ngidraw a tangent at time t2 kwi graph. I tangent leni izama ukungibonisa ini the gradient, ukuthi gradient injani, i gradient ye graph meaning the rate of reaction. Remember the gradient is the rate of reaction. Injani gradient ye graph at time t1 compared to i gradient at time t2. Ubona kanjani uline ma horizontal okokuqala une gradient ewu0. Waqala wangathi uyaphakama uyaslanta ilokhu yakhuphuka i gradient. The more lokhu slanta lokhu yakhuphuka i gradient. The more lokhu slanta uphakama uyaphezulu uyakhuphuka i gradient, yakhuphuka i gradient. So kuyayenza isense ukuthi uthi wena at time t1 the rate of reaction is higher than the rate of reaction at time t2 because i tangent yethu ikhuphukela kakhulu at t1 compared to i tangent yethu at t2. Angazi noma niyangithola. So the rate at t1 is greater than the rate at t2. Why ngithi rate? Because I rate i gradient vele. I reason yokuthi ngithi mina the rate at t1 is greater than the rate at t2 ukuthi because the slope at t1 is greater than the slope at t2. Angazi noma niyangithola. And into okumele uyazi nge-reaction ukuthi as the reaction proceeds iya ngokuyi lokhu inciphi rate of reaction, ilokhu inciphi rate of reaction meaning i-gradient ilokhu incipha. Angithi uyayibona igraph yami iqala yakhuphukela kakhulu, yakhuphukela ilokhu yakancane, ikhuphukela kancane, ikhuphukela kancane, ikhuphukela kancane. Isifika ku point X to Y ayisakhuphukeli at all meaning i-horizontal. Kusho ukuthi i-gradient, remember ngithe uline ma horizontal une gradient ewu0. Kusho ukuthi at point X to Y the gradient is 0 meaning the rate of reaction is 0 meaning the reaction is no longer occurring. Angazi noma niyangithola. So uportion XY kahle kahle ilapho khona i-reaction isireache i-completion, kusho ukuthi seziqedile ukureacta. That's why ubona sekungena change in amount of any substance masingayibeka ngaleyo ndlela. I hope niyangithola. Uma ungayizwa kahle kodwa uphinde uyiphinde ivideo uzoyizwa. Now let's consider nayi futhi graph. Kubalekile concentration futhi versus time, but already sesiyazi ukuthi the slope noma the gradient is the rate of reaction. Basinikezile ke graph yethu siyabona ama products. Ngibona ngani ukuthi ama products, ngibona ama graph amayakhuphuka. Now sekunama graph awu2. Yes, ugraph 1 ama products, ugraph 2 or ama-products siyavumelana ngithi. Izikhuphukile-ke lezi zinto ugraph 1 nograph 2 zase zareacha ipoint lapho khona sezi-horizontal zo-2 ilapho khona i-amount of each graph sekubani noma of each product sekubani isiwu-A ingasakhuphuki ingasehle upoint X-ke lowo to point whatever. Kusho nje mabengabuza ukuthi mhlambe i-reaction iphele nini for ugraph 1 ungasho ukuthi iphele lapha at time t1 angazi noma niyangithola because yona reach completion at point X graph 1 and then graph 2 yona uyi-reach nini completion uyi-reach at time t2 point Y ngithi uyi-reach lapho because iqala khona ukuba horizontal. Uyambona ukuthi ugraph 1 uqala at point X ukuba horizontal, ugraph 2 uqala at point Y ukuba horizontal. Usuyabona ukuthi kusho ukuthi u-T1 urepresenta ini isikhathi esithathwe ugraph A to reach completion noma to react and then u-T2 urepresenta isikhathi esithathwe ugraph 2 to reach completion. Noma niyayithola. Now singakwazi ukuconclude lapha ukuthi the rate of reaction for graph 1 is higher than the rate of reaction ku graph 2. I-reason ukuthini awuhlali ungakhulumi ngeslope because islope yiso vele esikhuluma nge-rate of reaction. Uzothi because islope at graph 1 is steeper noma is higher than the slope ku graph 2. Ungakhulumi ngesikhathi kakhulu because sinayo into vele ekhuluma nge-rate of reaction okuyi-gradient. Never mind isikhathi, nasi isikhathi besokutshela. Nayi kenye mistake yenziwa abafundi banikezwa ama-experiments awu-2. Thothi experiment enye ithathe 5 hours, enye experiment ithathe 3 hours. Uzovele ithathe le enesikhathi esikhulu bese ethi rate high, ubona isikhathi si high, usethi ne-rate high. No, ayihambi kanjalo. I-rate high ile ethathe isikhathi esincane because kusho ukuthi lokuba used up nokufomeka kwenzeke very fast kusho ukuthi rate high because i-rate of reaction ikhuluma ngani ngokuba used up nokufomeka as isikhathi siqhubeka. So if leyo process yokuba used up nokufomeka yenzeka very quick kusho ukuthi isikhathi sisoba sincane isikhathi se-reaction. If yenzeka very slow kusho ukuthi isikhathi se-reaction sisoba sikhulu. Isikhathi asihambisani ne-rate. Isikhathi mase sikhulu i-rate incane, isikhathi mase sincane i-rate high. Angazi noma niyayithola leyo nto leyo. Now ngokwazi kwethu-ke sazi ukuthi thina njengoba zi-reactor lezi zinto lezi kuba khona izinto ezenzakalayo noma kuba khona ama-bond abreakekayo ukuze kuzofomeka u-C no-D mag-react to-A no-B. Angazi noma niyayithola leyo nto uma singayibuka at a molecular level ukuthi why u-A no-B be-reactile kwafomeka u-C no-D. U-A no-B bazokwenza njani? Bazobreak ama-bond and then beyobonda ngendlela ababonda ngayo to form enye into okuwu-C no-D engaseyena u-A no-B. So during yona-ke leyo chemical reaction noma chemical bonding sikwazi ukusebenzisa i-collision theory. I-collision theory yasisiza ukusichazela ukuthi i-rate of reaction-ke i-affecteka kanjani noma kwenziwa yini ukuthi i-rate of reaction ibe ncane komunye ibe nkulu. I-collision theory-ke ithi yona for a reaction to occur ama-molecules kumele be well orientated, kusho ukuthi kumele be ready ukuthi sesiya-reactor-ke manje. Again ama-molecules mase well orientated azostarta move faster with sufficient average kinetic energy. Remember ukumove faster has everything to do with the kinetic energy vele. And then kuzoba na more effective collisions mawukuthi ama-molecules ase-move faster. Njengoba neyimoto wazi ukuthi speed kills, kusho ukuthi imoto mayigijima zizoshayisana kakhulu, ama-collisions azoba maningi. Niyazi ukuthi i-collision bayayifanisa nokushayisana. Kubalulekile ukuthi ukwazi ukusebenzisa i-collision theory to explain ukuthi why lo omunye ebe ne-rate high, why lo omunye ebe ne-rate low. But kusho ukuthini kuba ne-rate high, kusho ukuthini kuba ne-rate low. Kubaluleke ngani futhi ukuthi i-rate ibe high noma ibe low? Asiconsider futhi i-reaction yethu A no B to produce u-C no D. Thina if ikhampani sikhanda mhlambe u-C no D sisebenzisa u-A no B to form u-C no D. Kubaluleke kakhulu for thina as ikhampani ukuthi u-C no D befomeke very fast. Why sifuna befomeke very fast? Ingoba sifuna ukubadayisa phela njengekhampani senze profit. Angithi ngeke sikujabulele ukuthi u-C no D kumthathe 5 years ukuthi efomeke. Singajabula ukuthi u-C no D befomeke maybe in a couple of weeks or months if kuyenzeka. Angazi noma niyayithola leyo nto leyo. So ngamanye amazwi akhona ama-factors a-affect i-rate of reaction. Nanoma i-rate of reaction ibizowuthatha u-5 hours, akhona ama-means esingawenza ukuthi igcine ithatha less than 5 hours. Sikhuluma ama-factors-ke manje affect i-rate of reaction. Eyokuqala i-temperature. I-temperature iya-affect i-rate of reaction. Nanoma bayi-increasile nanoma bayi-decreasile izo affecteke i-rate of reaction. Kanjalo ne-concentration, i-surface area, i-pressure, i-catalyst, ne-nature of reactants. Masithi nature of reactants sisho ukuthi ubunjalo bawo ama-reactants ukuthi ngiyinto kanje mina nakho kuyayi-affecta i-rate of reaction lokho. So ngi-increase any of these factors iya-increase i-rate of reaction. Decrease any of these factors iya-decrease i-rate of reaction. Ayenzeki i-mistake. Mawuke wayi-decrease nje i-temperature uhlala wazi ukuthi i-rate of reaction izo-decrease. Mawuke wayi-increase nje i-temperature i-rate of reaction izo-increase. Kanjalo ne-concentration, ne-surface area, ne-pressure, ne-catalyst. Si-explaina kanjani ukuthi lama factors ay-affecta kanjani i-rate of reaction? Si-explaina using the collision theory. Notha-ke njengoba kade ngishilo, an increase in any factors affecting the rate of reaction azo-increase nani ne-rate of reaction. I hope niyayithola leyo nto leyo, ibaluleke kakhulu ukuthi uyazi. Ithi sibheke-ke i-temperature ukuthi i-affecta kanjani i-rate of reaction. Asithatheni mhlambe i-situation lapho khona i-temperature i-increase. Manizokhumbula kahle kuyaphekwa emakhaya, think of istambu, isemp mabeyipheka abanye kweminye imizi bayipheka mhlawumbe uzoyibeka estofini ngo-8 ebusuku esibeke ku-1 istofu bese uzovuka ekseni sezivuthiwe istambu kusho ukuthi sizophekeka overnight. Abanye bayakwazi ukuthi besibeke ngo-8 istampu bebeka istofu ku-maximum bese mhlawumbe after a couple of hours sezivuthiwe istampu. Kusho ukuthi i-temperature njengoba ngithi istofu siku-1 noma siku-4 if u-4 i-maximum i-temperature leyo. Kusho ukuthi kwenzakalani mawukuthi mina kwi-situation yestampu ngithatha istofu ngisibeka at maximum sizoshisa kakhulu istofu kusho ukuthi i-temperature high kuzokwenzakalani i-process yokupheka kwestampu izothatha less time kusho ukuthi the rate is high. If istofu ngisibeka ku-1 kusho ukuthi i-process yokupheka kwestampu ngoba i-temperature low izothatha long kusho ukuthi the rate is very low. I hope niyayithola leyo nto leyo. So into esiyaziyo ukuthini increasing the temperature increases the kinetic energy of molecules. Kusho ukuthi ma increase the temperature think of umbila lo westamp as ama molecules. Kusho ukuthi ma increase the temperature i-kinetic energy yawo kama molecules, in our case sikhuluma ngestamp ngithi kusho ukuthi i-kinetic energy yestamp izo increase. Konje kusho ukuthini uku-increase kwe-kinetic energy ama molecules will have kinetic energy angithi siyavumelana ama increase and then azo move faster. Niyayithola leyo nto i-kinetic energy mayisi enough kusho ukuthi azo move faster and then move faster, speed kills kusho ukuthi azoshayisana, more effective collisions per unit time will result and then the rate of reaction increases. Angazi noma niyangithola. Kusho ukuthi basically ngithi mina more increase in temperature and increase in temperature kuzo increase i-kinetic energy of molecules and then more molecules will have enough kinetic energy and then azo move faster and then more effective collisions per unit time will result. Angimbhalanga time lapha sorry but per unit time and then rate of reaction increases. Mhlambe mawungayibamba ngale analogy lengiyisebenzisayo ama-stamp nani uzoyikhumbula. And then the opposite is true for a decrease in temperature. Now let's consider i-concentration. I-concentration masingayicabanga mhlawumbe i-analogy esingayisebenzisa uyayazi ijuice abathi concentrated lebhala ukuthi dilute basho ukuthi mixe namanzi leyo juice leyo. Kusho ukuthi leyo juice isuke ine-concentration e-high. Angazi noma niyangithola. Uthatha ijuice mhlawumbe ku-1 liter kodwa manje sikhipha ujuice olingana ibhakede liwu-25 liter. Kusho ukuthi kahle kahle njengoba ilapha ku-1 liter le juice yethu iningi kahle kusho lokho ukuthi concentration i-high noma i-concentration iningi. So ma increase i-concentration usho ukuthini more molecules will be available per unit volume. Uyangithola isho ukuthini leyo nto leyo. Leli point nje lokuqala lithi more molecules will be available per unit volume in terms of juice. Isho ukuthi kule 1 liter le ye juice kahle mningi lo juice kule volume le e1 liter. Actually lo juice mningi kakhulu ngendlela ukuthi ukwazi ukulingana u25 liter. Isho kanjalo. So an increase in concentration izokwenza ukuthini more molecules will be available per unit volume and then more molecules with correct orientation and then more effective collisions per unit time and then rate of reaction increases. Usuqedile okwakho nje bekuthi uyibambele ngojuice sengama points lawa anormal. Uyabona kahle the only point elibalekile is the first point, the rest are similar. Angazi noma niyangithola. Again the opposite is true futhi ma uyi decrease concentration kusho ukuthi less molecules will be available per unit volume. Leyo nto engisho mangithi the opposite is true. And then masikhuluma ngepressure increased futhi nayo pressure ianalogy esingayisebenzisa ku pressure awucabange uthathe mhlambe isigubhu se2 liter ufake ama flies awu 3 kwisigubhu se5 se2 liter kusho ukuthi mangithi ama flies ngisho impukane mawuvalelela ama flies lawa phakathi kwisigubhu esi2 liter uyavuma ukuthi lama flies lawa ane space esiningi angakwazi ukuthi efly kuso without colliding with ama walls wesigubhu and without colliding with one another. Angazi noma niyangithola. But mase sithatha lesi sigubhu lesi sesisenza manje sibe from 2 liter to a half liter. Kwenza ukuthini ke lokho sekuzoba ne pressure manje eimpukaneni because manje isigubhu sesisincane kusho ukuthi si increase pressure eimpukaneni by making isigubhu sibe sincane. Uyazi vele an increase in pressure increase kanjani pressure by decreasing the volume. So I volume bekubani beku 2 liter now seku 0.5 liters kusho ukuthi decrease ileke I volume kanjalo ya increase pressure. So uyabona ukuthi kahle kahle impukane manje mase sisincane isigubhu sezi forced ukuthi zibe closer to each other ngazi noma niyangithola. Kanjalo zizokwazi ukuthi mayindiza kube lula ukuthi zicollide with each other noma zicollide with ama walls we container. Ibambe kanjalo ke analogy esisebenzayo but asikho lapho sila more increase pressure molecules will be forced to be closer to one another. Point number 1 law. And then more effective collisions per unit time will result. Singavumelana lapho mase zi closer to one another. Cabanga impukane and then rate of reaction increases. Uyayibona ukuthi kahle point 1 okumele umbambe okunye sekuyafana ngazi noma niyangithola. Again the opposite is true mabe decrease pressure. Kusho mabe decrease pressure impukane sezi free kusho ukuthi molecules will be far apart from each other ngazi noma niyangithola. Okay bese kuba surface area. My increase iwe surface area asiyithatheni ngale analogy surface area cabanga Norox cube noma beef stock leyabapheka ngayo. Abantu abaningi mabepheka bayathanda ukuthi leyashanisa leyana beyicrashe lebhodweni. Abanye bayayithatha njengoba iyicube injalo beyifake ekudleni. So uyicrashele ekudleni usuke wenzani usuke wenza ukuthi ioccupy isurface area eningi noma ibe spread all over isishebo iyona as icube angazi noma uyangithola. In that way mawuyicrasha uyenze njani uyenza ukuthi isurface area ibe increased. And then mawuyifaka njengoba injalo kusho ukuthi awu increase ange surface area. Now iyiphi ke esheshe iphele esishebeni isheshe idissolve ile ecrashiwe siyavumelana because le engacrashwanga izoqale idleke the outer surfaces ilokhu idleka the outer surfaces ilokhu idleka the outer surfaces ilokhu incipha in size kanti le oyicrashile vele inyamalala nje fast ekudleni. Why inyamalala leya because wonke ama parts wayo ibeef stock asuke exposed to the reaction akufana nale cube ukuthi ku exposed only the outer parts of inakhunja beef stock. So ihamba kanjalo ke surface area ma increase surface area you are actually exposing ama particles noma ama molecules to the reaction wonke kusho ukuthi more effective collisions per unit time kanjalo nene rate of reaction ya increase. Ungabuye ucabange njenge yini stick sweet leso enthanda ukusidla lesi phakathi sinalento engathi upowder emhlophe. Lesa stick sweet lesana mouse crusher already ipowder isi exposed kusho ukuthi mawuyicrusher u increase the surface area all the particles we stick sweet mangathi mhlambe particles azobe exposed to the reaction angazi noma uyangithola. Kanti if awuscrushanga meaning u decrease I surface area uzoqala lokhu simunca silokhu udleka kancane sincipha in size lokhu udleka kancane sincipha in size lokhu udleka kancane sincipha in size until ufika kuphi kulento le eyipowder kusho ukuthi kuzothatha longer than when si crushed kusho ukuthi ngamanye amazwi an increase in surface area kuzokwenza ukuthi more particles ebe exposed to the reaction more effective collision per unit time rate of reaction increase njengoba dengisho and the opposite is true futhi for a decrease in the surface area. Okay bese kuba i-catalyst ke yona awusho ukuthi increased but uthi added or removed. I-catalyst yona by definition vele is a substance that increases the rate of reaction by providing an alternative path of lower activation energy. That's how you define catalyst. So umsebenzi wayo vele catalyst increase the rate of reaction akudingeke analogy efunakalayo. Now mawukuthi ke ukhuluma nge-catalyst added uzoqale wenze ipoint lokuqala uthi catalyst increases the rate of reaction by providing an alternative path of lower activation energy. Kusho ukuthi udefine i-catalyst ku-point lokuqala, and then i-point lesi-2 molecules will have enough kinetic energy, and then kusho ukuthi azomove faster and then more effective collisions per unit time, and then rate of reaction increases. Into kanjalo. The opposite is true for when catalyst is removed. Okay, bese uba ama-nature of reactants. Ama-nature of reactant njengoba bengishilo ukuthi i-reactant yona injani ngokwe-nature yayo. Ama-nature of reactants abawabuzi kakhulu ukuthi wachaze ngeko-collision theory, but mangathiwa sikhuluma ngawo mhlambe kancane kuma-nature of reactants kukhulunywa ngokuthi ama-bonds aholde law akanjani compared to ama-bonds aholde law. Njengokuthi nje mhlambe mangathatha for example ngithathe umethane unani unama-London forces bese ngithatha upropanol una-hydrogen bonds, ubani one force strong ulo one-hydrogen bond kunalo omunye. Ungayibuka nalento ngeso lokuthini mawupheka inyama i-nature yayo inyama ukuthi ingasheshi ukuvuthwa compared to iqanda. Ama-nature of reactants basobe bekhuluma ngento kanjalo. Alidlule lapho ku-grade 11 nifunde nge-exothermic reaction. Nithemani define exothermic reaction, that is the reaction in which energy is released. Ngoka delta H i-heat of reaction esisazokhuluma ngayo, u-delta H we-exothermic reaction is less than 0, negative. Sometimes bavele bethi delta H is negative mhlambe 123 kilojoules for example. Usuyazi delta H is negative because u-123 u-negative. And then kube i-endothermic reaction, niyifundile kwa grade 11 ukuthi ini endothermic reaction. But more define what is the reaction in which energy is absorbed. We should see in terms of the heat of reaction noma enthalpy change, u-delta H uzoba greater than 0. And then njengoba ngisho ukuthi u-delta H is an enthalpy change. U-delta H kahle u-delta wazi kahle ukuthi u-change, sike sayikhuluma leyo nto leyo. U-delta H, remember u-delta is change, kusho ukuthi final minus initial ngendlela desisho ngayo. But now kuzoba ubani products minus reactants, energy of products minus energy of reactants kuzoba u-delta H lowo. Kubalekile futhi kwa grade 11 bekumele ngabe nifundile nge-activation energy. Activation energy mawuyidefine which is the minimum energy needed for a reaction to take place. Uyidefine kanjalo i-activation energy. U-activation energy representa u-EA, and then kube activated complex. Activated complex is an unstable transition state from reactants to products. Uyidefine kanjalo. Kubalekile ukuthi uzazi lezi zinto because zinama graphs wakhona. Masingathatha nje u-exothermic reaction, igraph yakhona iba kanje ya njengoba uyibona le graph engiyidrawile. Lapha ku B sinama reactants, kusho the energy of reactants iqala kuma reactants njengoba ubona, and then ama products alapha ku C the energy of products. Uyabona ngithi ku Y kuma Y axis kune potential energy, kusho ukuthi u C is the energy part of products and then u B is the energy part of reactants. And then ukusuka lapha ku B uyaphezulu ku A, that's the activation energy. Kusho ukuthi kusuka kuma reactants uya lapha ku turning point mangayibeka kanjalo usuke ukhuluma nge-activation energy u-EA, and then the difference between the energy of products and the energy of reactant kusho ukuthi difference between u-C no B, that's the enthalpy change noma u-delta H. So in this case u-delta H uzoba njani ke, uzoba less than 0. Ngenza mistake lapha ngikhohle ukufaka u-H, but that's delta H or negative. Remember delta H is energy of products minus energy of reactants. Uyambona u-C number encane, u-B unumber enkulu, kufana nokuthi 2 minus 5 uzothola u-negative 3. That's why u-delta H n negative. Lapha phezulu edotini njengoba ngibona ngibeka idot i-activated complex lade ngikhuluma ngayo. And then kube i-endothermic reaction niyifundile futhi nayo kwa grade 11, but kubalekile ukuthi niyazi lento lena. Okay, basinikezile igraph ye-endothermic reaction njengoba uyibona. Ku C sinama reactants, ku B sinama products, and then ukusuka kuma reactants uyaphezulu ku turning point, meaning ukusuka ku C uya ku A i-activation energy. And then the difference between u-B no C, that's your delta H. So in this case u-delta H uzoba njani? Remember u-delta H is energy of products minus energy of reactants. Kusho ukuthi inamba enkulu minus inamba encane, kufanele ukuthi 5 minus 3 uzothola i-answer positive. Kusho ukuthi delta H wethu positive. Angazi why bese ngasambhala u-delta lapha, sorry. Ihamba kanjalo ke, then sibe ne-activated complex lapha. Uma udefine i-catalyst niyakhumbula sithe is a substance that increases the rate of reaction by providing an alternative alternative path of lower activation energy. Mawikhulumisa ke le hanti ithini iya increase i-rate of reaction but i-provider i-path entsha manje ye-activation energy and leyo path leyo it provides i-activation energy elower. Ngikhohle ukubhala u-path lapha kwi-definition. Isho ukuthini ke lento ngokwe-graph? Nayi i-graph sinikeziwe siyavumelana ukuthi sibile ne-activation energy okusuka ku-B kuya ku-C siyavumelana. That's the activation energy. Now mangathiwa bathi bona redraw le graph le and then on the same set of axes draw ukuthi kuzokwenzakalani ngale graph lena mase be-add i-catalyst. Wena wazi ukuthi i-catalyst yenze njani? It provides an alternative path of lower activation energy. Kusho ukuthi activation energy njengoba kade iyinde ingakayana noma inkulu njengoba uyibona isizoba ncane manje uyirepresenta leyo nto ngama dotted lines. Uyabona ama dotted lines wami lawo ngwabhalayo. Check ukuthi activation energy sezoba ngakanani. Remember activation energy izosuka ku B kuma reactants iye lapha ku turning point. Sekuyinto encane manje uyibona leya line leya activation energy sincane. Kanjalo mawu removile futhi catalyst banokusho ukuthi i-remove the catalyst kusho ukuthi uzodraw ama dotted lines but i-turning point yama dotted lines wakho isizoba phezulu kunale turning point adunayo initial because bayi-remove i-catalyst. Khona futhi enye i-curve ebizwa nge-Maxwell-Boltzmann distribution curve. I-Maxwell-Boltzmann distribution curve yona i-curve eshowa ukuthi i-impact of an increase or a decrease in temperature i-affecta kanjani i-amount noma number of particles are taking part in the reaction. Kanjalo nokuthi i-catalyst may-added noma i-removed i-affecta kanjani futhi ama-particles are taking part in the reaction. Nayi-ke i-graph ibizwa nge-Maxwell-Boltzmann distribution curve. Kuba i-graph ekanje. Leya line leyana vertical i-representa the activation energy. And then asithi mhlawumbe basinikeza i-graph temperature of 300 degrees Celsius. Leya shaded region njengoba ubona ngiyi-shader i-representa ama-particles are overcome the activation energy. Remember the activation energy is the minimum energy needed. Kusho ukuthi ama-particles akuleli side elikwa left ka EA are not taking part kwi-reaction because ane-energy less than the minimum required. Angazi noma niyangithola. And then ama-particles are on the right hand side of EA ane-energy enkulu kuno EA. Kusho ukuthi ane-energy greater than the minimum required. Kusho ukuthi they're actually taking part kwi-reaction. Now let's consider when be-increase ile temperature. Remember na i-graph yethu le ngathi orange. Le graph e-orange eka 300 degrees Celsius. Angithi sivumelene siyibonile. Uyabona ukuthi laphana le nto engisayi-explain ukuthi mangingabuka ugraph o-orange unama number of particles amaningi the maximum lapha phezulu. Angithi uyabona lapha engiseklishe khona ngo-red. U-black yena i-maximum yakhe lapha phezulu ama-particles amancane kunalawa ka-graph o-orange. But leyo nto leyo asinendaba nawo lama-particles lawa. Why singenandaba nawo? Because ane-energy encane wona. Mawungathi mhlawumbe uyayibheka i-energy yakhona incane i-energy yakhona kune-minimum required. Uyabona mase ngichecka lama-dotted lines engiwadrawa manje ahamba eye ku-graph o-black na ku-graph o-orange ngala kwe-activation energy sithola ukuthi now i-amount ka-graph o-black isinkulu kune-amount ka-graph o-orange. Angazi noma niyangithola. Into engizama ukisho ukuthi mawu-interpreta le graph le ungafocasi kuma-particles akwa-left kuka-EA. Focusa kuma-particles akwa-right ka-EA. So kwa-right ka-EA ugraph o-black uye onama-particles amaningi. As you can see ama-particles akhona uyabona ukuthi lapha kuma-y-axis inamba yakhona ibizoba nkulu than ne-graph e-orange. So mangathiwa bebethi mhlambe iyiphi-ke ne-temperature enkulu laphana ubuzokwazi ukuthi shuthi le e-black le e-orange ine-temperature encane because i-shaded region laphana yakhe ugraph o-orange incane kune-shaded region ka-graph o-black. I hope uzizwene lapha but nama ngizizwa ukuthi ngithini but iyo lento engiyishoyo. So i-focus yethu nje iba kwi-shaded region origin kuphela because yiwo ama-particles atake i-part kwi-reaction. And then masibuka yona futhi Maxwell-Boltzmann distribution curve sibuka nge-catalyst manje. Remember i-catalyst increase the rate of reaction by providing an alternative path of lower activation energy, and ama-particles athatha i-part kwi-reaction lawa angala lawa engacyclishayo ngo-black yiwo kuphela athatha i-part kwi-reaction. Mabe ngathi the catalyst is added la kusho ukuthi silindele ukuthi i-activation energy siyibone iya kwa-left. Remember inamba iqala from 0 ziyakhuphuka ziya le, so ukuze ehle i-A silindele ukuthi approach u-left kusho ukuthi approach u-0 because vele i-catalyst umsebenzi wayo is to provide an alternative path of lower activation energy, kusho ukuthi it decreases the activation energy. Uyabona mase ngidraw iline laphana yenzeni leya line leyana i-activation energy mayise incane ivele ya increase leli side elikwa right of i-activation energy ngoba ngibona ngicyclisha ngo-red. Ileyo nto mawufunda ngama-rate of reaction ebalulekile okumele uyazi. Ngicela ningixolele if angi-explainanga kahle kuma-graph, ngiyoni-explainela kahle mhla nginibona ey'koleni zenu uma nginivakashela ukuze ukwazi ukuphendula lama questions because kuba ama-questions wama-experiments. Kubalulekile ukuthi wazi ukuthi yini dependent variable, yini independent variable, yini controlled variable, yini investigative question, yini i-hypothesis, yini i-conclusion on any experiment. Ma umfundi nje we-science kumele uyazi leyo nto leyo. I-dependent variable i-variable edepende kwenye ukuthi mhlambe mina ngizokwenza kanje because lo uwenze kanje, mina ngizo-increase because i-temperature i-increasile. Kusho ukuthi i-rate of reaction iyi-dependent variable, idepende kwi-factor e-affectayo. Angazi noma niyangithola. Fana nokuthi uthi wena mina ngizogqoka ijezi because kuyabanda, kusho ukuthi wena ukugqoka kwakho ijezi kudepende on i-weather. Ihamba kanjalo lento yama-dependent and independent variable. So usuyazi ukuthi independent variable yini, i-weather ayidependanga kuwe ukuthi uligqokile ijezi noma uligqokanga, uma ukuthi bekuzobanda kuzobanda. Independent variable into kanjalo. And then i-control variable into eyenza ukuthi mayingenziwanga yaba constant izoyi-affecta lento ezizama ukuyi-check. Angazi noma niyangithola. Kufana nokuthi sifuna ukubona ukuthi i-rate of reaction i-affectwa yi-temperature kanjani, bese thina i-concentration yethu singayenzi ibe constant for ama-experiment wonke. Izo-affecteka ke i-rate of reaction kanjalo ngoba kwayona i-concentration vele iyi-factor e-affecta i-rate of reaction. Angazi noma niyangithola. Into engizama ukuyisho la ukuthi kule chapter esikuyo i-dependent variable i-rate of reaction always, i-independent variable ilama factors o6 always, i-control variable yiwo futhi o6 always. So let's say for example kwi-experiment yakho sifuna ukucheck ukuthi i-temperature i-affecta kanjani i-rate of reaction. Kusho ukuthi i-concentration kumele ibe controlled, i-pressure kumele ibe controlled, i-surface area kumele ibe controlled, nakho konke okunye ngaphandle kwale i-temperature. Angazi noma niyangithola. And then investigative question, i-question ebuza about the relationship between the dependent and the independent variable. For example, what is the relationship between an increase in temperature and the rate of reaction? Noma how does an increase in temperature affects the rate of reaction? I-investigative question kumele kube i-question okusho ukuthi kune question mark ekugcineni, and akumele kube i-question othi ma uyi-answera kube i-answer ethi yes or no. Angazi noma niyangithola. Njengokuthi does an increase in temperature affect the rate of reaction? I-answer yes, akumele kube kanjalo. You ask about the relationship between the dependent and independent, but i-answer kungabu yes or no. And then i-hypothesis ilento lena esiyifunda kuma notes. Kusho ukuthi njengokuthi ngizoperform i-experiment but theoretically ngiyazi ukuthi mangenza lento kuzokwenzeka lento. I-hypothesis upredict into ezokwenzeka. Angazi noma niyangithola. And then i-conclusion kuyasho ukuthi ngoba sengiyiperformile experiment ilento eyenzekile uyaconclude. Ningakhohlwa ke ezingishilo ukuthi ama factors affecta i-rate of reaction onke lawana. Okay, njengoba bengishilo niyakhumbula ama factors affect i-rate of reaction, i-temperature, i-pressure, concentration, surface area, catalyst, ne-nature of reactants. In terms of dependent and independent variable, i-rate of reaction ihlezi i-dependent variable throughout the chapter. Idepende kuphi kuwo o6 lama factors noma ku one of of the 6 factors affect a rate of reaction lawe ngiwanamile njengoba niwabona. Now nayi into ebalekile ku-exam bakunikeza into kanje nali table. Ngifuna ukuthi sikwazi ukuthi sili-interpreta kanjani noma i-data mabesinikeze yona si-interpreta kanjani. Leli table lena basinikeza u-experiment 1 no-experiment 2 into engiyibonayo ku-table. Ngino-zinc uyi-powder ku-experiment 1 uyi-powder ku-experiment 2. I-powder isho ukuthini an increased surface area. It's either bizoba i-powder noma iba ama-granules. Mayi-powder kusho ukuthi ba-increase i-surface area, mayingayona i-powder abayi-increase. Ngaphinde ngaba nani hydrochloric acid ngaba ne-concentration ka-HCl ngaba ne-concentration ka-HCl. Ngaphinde ngaba nani ne-temperature, i-temperature kabani ka-experiment 1 no-experiment 2. La kuvezwe ama-factors awu-3 a-affecta i-rate of reaction. Baveze i-surface area, baveza i-concentration, baveza i-temperature. Umbuzo uzobuza ukuthi iyiphi factor aba-investigatayo ile engafani kuma-experiments mawubheka. Kusho ukuthi njengoba u-experiment 1 nje ngibona ukuthi i-concentration u-0.1 ku-experiment 2 but khona u-0.2 kusho ukuthi ba-investigator i-concentration. Angazi noma niyangithola. I-must ukuthi ukuze ibe fair i-experiment kube ukuthi vele i-surface area ku-experiment 1 naku-experiment 2 iyafana njengoba ifana nje kuyi-powder. I-must futhi ukuthi i-temperature ku-experiment na experiment 2 ifane kube u-25 njengoba ubona, because ku-experiment noma kuma-experiments mayenziwa kumele ibe yi-1 i-independent variable. Angazi noma niyangithola. Kusho ukuthi mangathiwa nje bebekubuzile lana ukuthi ubani i-dependent variable, ubuzothi rate of reaction. Ubani independent variable, concentration of HCl. Ubani controlled variable, u-surface area no temperature. Why sithi control? Ngoba iyafana kuwo O2 ama-experiments. Angazi noma niyangithola. Asibuke nayo futhi enye experiment. Basinikeze laphana u-experiment 1, 2, 3 and 4. Mangithi ngicheck u-experiment 1 ngiyabona ukuthi okay ngine-mass ewu-10, concentration ewu-2, temperature ewu-5 and then granules kusho ukuthi the surface area is not increased. Kanjalo namanye ama-experiments ngiyabona ukuthi khambana, ngithi niyabona. Mangaka ama-factors lana bawabhalile a-affect rate of reaction. Ngiyayibona i-concentration, ngiyayibona i-temperature, ngiyayibona i-surface area masingasho kanjalo mhlambe. Kufair yini ukuthi mhlambe compare u-experiment 1 and 2? Mhlawumbe umbuzo mangathi uyabuza kufair yini ukuthi compare u-experiment 1 and 2? Yes, kufair ukuthi compare u-experiment 1 and 2. Why? Because u-experiment 1 and 2 there's only one independent variable. Kusho ukuthi iyodwa into engafani okuyi-concentration. Angazi noma niyangithola. So okuyi-temperature. Angazi noma niyangithola. Mabebuza ukuthi kufair yini ukuthi compare u-experiment 2 and experiment 4. No, akukho fair because there's more than one independent variable. Yini? I-temperature ayifani, i-state of calcium carbonate noma i-surface area futhi ayifani. Akumele kube kanjalo. Awukwazi ukucompare if i-independent variable iyodwa. Kumele kube ukuthi awukwazi ukucompare if i-independent variable ayikho yi-1. Kumele kube ukuthi i-1 independent variable, the rest zifane. Angazi noma niyangithola. As you can see ku-experiment and experiment 2, i-mass u-1010, i-concentration u-22, i-state of calcium carbonate granules. The only difference is in i-temperature enyu-25 enyubani enyu-15. Singavumelana ku-experiment 1 uyo ozoba ne-rate high because une-temperature high. Angithi ihamba kanjalo ke niyibheke lezo zinto lezo. Nayo futhi enye into ebaluleke kakhulu bakunikeza i-reaction njengoba uyibone kanje. U-zinc, u-HCl ba-produce u-zinc chloride no-hydrogen gas. Njalo mawenza lento lena ucheck ama-phases wawo ama-reactants wakho. Uyambona ukuthi u-zinc wami uyini, uyi-solid. Uyambona ukuthi u-HCl wami uyini, uyi-aqueous. Mabe ngathi bona yini ongayenza kule experiment uku-increase the rate of reaction? Okokuqala nje yonke into iya-affectwa i-temperature. Kusho ukuthi i-answer yokuqala nje kumele ifike engqondweni i-temperature. Niyangithola. After i-temperature into okumele ifike engqondweni i-catalyst, niyangithola. Okunye-ke sekungalandela bavele bekulaye kwi-exam bevele bethi besides i-temperature ne-catalyst yini ongayenza uku-increase i-rate of reaction la wena uvele uthi pressure, increase pressure. Yes, uku-increase i-pressure kuya-affect i-rate of reaction, kuya-increase, but not in this case, because in this case ama-reactants wakho akuwona ama-gas kanti i-pressure ikhuluma ngama-gas. Angazi noma niyangithola. Awukwazi wena ukuthi ukhulume nge-pressure ekubeni ama-gas ungawaboni. Angazi noma niyangithola. So the only thing obekumele ifike engqondweni yokuqala ukuthi uzinc uyisolid, kusho ukuthi bekumele ngi-increase i-surface area yakhe, ngimcrushe. Enye into futhi obungayenza uku-increase i-rate of reaction, ubungenze njani? Ubunga-increase i-concentration ka-HCl, because u-HCl uyi-aqueous. Angazi noma niyangithola. Into ebaluleke kakhulu le ukuthi niyibheke manidila nalama problems kuma-exams. Another thing, nibe careful manenza ni-calculate i-rate of reaction. Remember, rate of reaction iya-calculator kuya nge-information abakunikeze yona, hhayi ukuthi uhlezi usebenzisa i-concentration ma ucalculator i-rate of reaction. Kuya ngokuthi bakunikeze ini, uchecka kanjani ukuthi bafuna ukuthi uyi-calculate kanjani i-rate of reaction, uchecka ama-units abakunikeze wona. Bakutshela ukuthi calculate the rate of reaction in, njengalawo yabo bathe in moles, in mole per second. Kusho ukuthi bafuna ucalculate i-rate ibe in mole per second. Ma uzokhumbula-ke i-maths, u-mole per second uyafana no-mole over second. In a negative exponent uyibuyisa ngaphansi be-denominator, exponent iba positive. Isho ukuthini-ke le nto le? Isho ukuthi kwi-formula lakho le-rate of reaction, i-numerator yakho kumele kuba ama-moles and then i-denominator yakho kube yini? Ama-seconds isikhathi. Mangathiwa nje bebethi sisebenzise le table to calculate the rate, bese singekho happy nge-numerator yethu because iyama-grams i-mass, kanti bona i-numerator yabo kwi-rate bafuna iba ama-moles. But kulula ukuthi singathatha ama-grams siwayise kuma-moles because siyazi ukuthi i-mass kabani ka-Zn uzinc, basibonisile kwi-table ukuthi bakhuluma nge-mass ka-zinc. Angazi noma niyangithola. Kwi-exam into abayenzayo bayakutshela ukuthi calculate the rate at 8 seconds. Mabethi calculate the rate at 8 seconds, usebenzisa izinto ika-8 seconds kuphela. Kusho ukuthi ubuzosebenzisa lo ya 0.010 no 8 seconds. Ube careful ukuthi bayifuna kuwama-moles noma kuwama-grams, because kuyenze kuba grams per second. Kusho ukuthi bese ngesi-convert ama-grams bese wafana nje obe njalo. But ma ukuthi bathe moles, so thatha lama-grams siwenza ama-moles bese sithi leyo answer over 8 i-rate leyo. Angazi noma niyangithola. But mabethe bona calculate the average rate of reaction for the first 8 seconds. Uyawuza umehluko. Calculate the rate at 8 seconds, calculate the average rate for the first 8. Mabethi for the average for the first 8 kusho ukuthi uthatha from time 0 to time 8. Uyabona ukuthi ku time 8 kusho ukuthi final minus initial, final ku 8, initial ku 0. Kusho ukuthi bezothini 0.010 minus 0.016 over 8 minus 0, ngoba bathi the average. Umehluko lowo ke. Ngiyabonga.